Today's topic is salts. Now let us understand what are salts. If you see this is hydrochloric acid, sulfuric acid, nitric acid. This is formic acid, also known as methanoic acid. This is acetic acid, also known as ethanoic acid. Now they all are acids because they have H plus ions or hydrogen ion as positively charged ion. This one, sodium hydroxide, potassium hydroxide, copper hydroxide, iron hydroxide, they all are bases because they have negatively charged hydroxide ions. If you see this now, this is sodium sulfate, calcium chloride, potassium nitrate, copper sulfate. So all these compounds, they have positives and negatives. This metals have tendency to form positive ions. So this sodium out here is positive, sulfate is negative, right? Calcium, if you see, it's positive. Here chloride is negative. In this one, potassium is positive, nitrate is negative. Here copper is positive, sulfate is negative. So all these compounds, they have positives and negatives, but the positive is not hydrogen ion and negative is not hydroxide ion. So such substances are called salts. Now you all are well aware that salts are formed by neutralization reaction. That is, when an acid reacts with base, a salt and water is formed. Now in this salt, the positive part, the positive ion comes from a base. So sodium out here being a metal forms a positive ion. So it comes from a base, sodium hydroxide. And this is negative ion, chloride ion. It comes from acid, right? So in a salt, the positive ions are always from base and the negative ions are always from acid. Now if you observe this table, in this table some salts are given, their formulas, their family, and from which acid and from which base they are formed. If you know the formula of any salt, you can predict or you can find out from which acid and from which base they are formed. If you take example magnesium sulfate, so you know magnesium being a metal forms a positive ion and positive ion always comes from a base. So magnesium sulfate is formed from a base magnesium hydroxide. While this negative part sulfide ion, this comes from an acid. So it is formed from sulfuric acid. So if you know the formula, you can tell the acids and bases from which that particular salt has been formed. Hydrolysis of salt in aqueous solution. Hydro means water and lysis means breakdown. You all are well aware that salt is a compound which is formed by neutralization reaction between an acid and a base. Now when a salt is added in water, it will furnish cations and anions. Example, sodium chloride, if you add in water, it will form sodium cation and chloride anion. These cations or anions formed during the ionization of salt either exist as hydrated ions or they will interact with water to regenerate the acid and the base from which that particular salt was formed. And this process of interaction between the cation or anion of salt and water is known as hydrolysis of salt. And on the basis of this hydrolysis, salts are divided into three categories: acidic salt, basic salt, and neutral salts. Let's see the different kinds of salts. The first one, acidic salt, example ammonium chloride. Now this salt, when it is added into water, then ammonium ion and chloride ion get separated and they react with water to form the base ammonium hydroxide and the acid hydrochloric acid. And these are the base and the acid from which this salt was formed. So as it is added into water, you get back this ammonium hydroxide and hydrochloric acid. Now you all know that hydrochloric acid is very strong acid. So it will form more number of H ion compared to OH ions. So the solution of this salt, ammonium chloride, will be acidic in nature. That means the pH value of the solution will be less than 7. Now second one, neutral salt, sodium chloride. Now sodium chloride is formed by a strong base, sodium hydroxide, and a strong acid, hydrochloric acid. So in the solution of sodium chloride, the H ions and OH ions will be in equal number. So it is considered to be a neutral salt and the pH will be 7. Now the third one, basic salt. This is sodium acetate. Now sodium ions, they will form sodium hydroxide and acetate, acetic acid. Now OH being, or the sodium hydroxide being a strong base, will give out more number of H ion compared to this weak acid. So in the solution of sodium acetate, the number of OH ions will be more. So the solution will be basic in nature and the pH will be, the value of pH of this solution will be more than 7. Now here I've given a table. You can go through this table in which there are salts being written and what could be the nature of the solution. That is when the salt is dissolved in water and why, right? For example, if you take ammonium nitrate, so ammonium nitrate is formed from ammonium hydroxide and nitric acid. Ammonium hydroxide is a weak base and nitric acid is a strong acid. So the nature of the solution will be acidic. So this way, from which base and from which acid the salt has been formed, you can predict the nature of the solution, whether the solution is going to be acidic, that is pH is going to be less than 7, or it is going to be, the pH is going to be 7 of a particular solution, or it is going to be more than 7. Some salts, they contain water molecule and they are known as hydrated salt. So hydrated, that means they have water in it, and the water molecule that is present in the salt is known as water of crystallization. So here are certain salts that contain water of crystallization. They are hydrated salt. This dot 5H2O means here that water is loosely attached to it, and these are the common names. While chemically, if we take this compound, this salt, this is known as copper sulfate pentahydrate. Penta means 5. So it has 5 water molecules attached to it. This is another one, sodium sulfate decahydrate. Deca means 10 water molecules attached to it. This is calcium sulfate dihydrate. That means 2 water molecules are attached to it. This is ferrous sulfate heptahydrate. That means 7 water molecules attached to it. This is zinc sulfate again, heptahydrate. This is magnesium sulfate heptahydrate. So some of the salts, they contain water molecules attached to it, which is known as water of crystallization. Here copper sulfate pentahydrate, that is CuSO4 5H2O. This blue color copper sulfate, it is blue in color, and it is blue in color because of the presence of this 5 molecules of water, and it is crystalline in nature. Crystalline in nature means that atoms, ions that are present in this salt, they are having some definite arrangement. There is proper arrangement of the atoms or the ions that are present in it. Now what happens if we heat this compound? So when we heat this compound, what happens? The copper sulfate, which is blue in color, it crumbles down into white powder, and on the cooler part of the test tube you will see water droplets, right? And the blue color will turn to white color. So as soon as the water is removed, this was hydrated salt, it had water in it. As soon as it is been heated and water has been removed from it, it becomes anhydrous, and the color from blue turns to white, and it becomes a white powdery substance, right? And when this in the white powder, if it when it cools down and you add again water into it, it will again become blue in color. So this indicates that because of the water of crystallization, or the five molecules of water that were present in it, it was having the blue color. Another example, ferrous sulfate heptahydrate. So it has seven water molecules. So if you heat it, this seven water molecules are going to evaporate, and this green color hydrated salt will become anhydrous. It will become white in color, right? And of course, if you further heat it or strong heating is done, then it will decompose into simpler substance, that is thermal decomposition will take place. Now here are the characteristics of salt. Most of the salts are crystalline in nature. They are transparent, or they may be opaque also. Most of the salts, they are soluble in water. Solution of the salts can conduct electricity because they form ions when they are dissolved in water, right? So they can conduct electricity. They can also conduct electricity when they are in the molten state, because in the molten state also ions are separated, but of course not in the solid state. The salt may be of different taste. Neutral salts are generally odorless, that is, they don't have any smell, and salts can be colorless, or they can be colored, like copper sulfate, which is blue in color, iron sulfate, which is green in color. Now we'll talk about sodium chloride, common salt also we call it, and the formula is NaCl. Sodium chloride is obtained by neutralization reaction. When hydrochloric acid reacts with sodium hydroxide, we get this salt, sodium chloride, and water. The sodium chloride is used in food also, and it is neutral in nature because it is formed from a strong acid and a strong base. So the solution of sodium chloride will have a pH of 7, so it's neutral. And this salt is obtained from seawater by the process of evaporation. Seawater is trapped in large shallow pools and allowed to stand there, and the sun heat evaporates the water slowly, and this common salt is left behind. Salt is further made pure by recrystallization process. The large crystals of common salts are often pinkish brown due to impurities and some minerals that are present in it. These are known as rock salt. Beds of this rock salts were formed when seas of bygone ages dried up. Rock salt is mined like coal. Now, let's understand the difference between the common salt or the table salt, which is white in color, and this Himalayan pink salt, or what we call as rock salt also, and Sendha namak, right? What's the difference between the two? The formula is same, NaCl. This is also NaCl, this is also NaCl. But then here it is pinkish brown in color because of the presence of certain minerals, and it improves our blood circulation. It contains natural iodine. It does not contain any artificial compound, and it is good in taste also. While this white table salt or the common salt, in this no minerals are present due to purification process. If you consume this in excess, it leads to high blood pressure, and here iodine is added artificially. It contains anti-caking compounds. Anti-caking compounds are those which absorb moisture and does not allow the salt to turn into lumps, and it is less favorable than the Himalayan pink or the rock salt. Now, when this electricity is passed through an aqueous solution of sodium chloride, what we call as brine. So, brine is aqueous solution of sodium chloride. So, the sodium chloride will decompose into sodium hydroxide. Along with that, hydrogen and chlorine gas will be formed. And this process is known as chlor-alkali process. Chlor stands for chlorine and alkali stands for sodium hydroxide that is formed in this process. That's why it is known as chlor-alkali process. Now here the electrolysis of sodium chloride is shown. In this we have anode, which is connected to the positive terminal of the battery. This is cathode, connected to negative terminal of the battery, and here we take the brine or the aqueous solution of sodium chloride. So when the current is passed through it, then what happens? NaCl forms sodium ion and chloride ion, and water forms H ions and OH ion. Now these both are positive ions, so they will move towards cathode, while these two are negative ions, so they'll move towards anode. So at cathode, what happens? Hydrogen gets discharged and forms hydrogen gas, and at anode, it is chloride ion that gets discharged and form chloride ion. While in the solution, sodium ion and OH ion remain and they form sodium hydroxide. So at cathode, we get hydrogen gas, at anode we get chlorine gas, and in the solution we get NaOH. So that means when the electrolysis of sodium chloride is carried out, we get three useful substances, and all three are very important. Now here you can see all the three substances that we get from NaCl. This is hydrogen, this is chlorine, and this is NaOH. And here you can go through it. All the uses of all these three substances that are obtained are given. Let's take another salt, that is bleaching powder. The chemical formula is CaOCl2. Chemical name is calcium oxychloride. And how it is prepared? When chlorine is added to slaked lime, we get calcium oxychloride and water. Now uses, it is used for disinfecting, to clean water, moss remover, weed killer, etc. It is used for bleaching of cotton in textile industries, wood pulp and paper industry, and it is also used as an oxidizing agent. Baking soda, chemical formula is NaHCO3. Chemical name is sodium bicarbonate. Preparation, sodium chloride, ammonia and water and carbon dioxide. They all are mixed and we get sodium hydrogen carbonate or sodium bicarbonate, and this is ammonium chloride. And where is this used now? It is used as antacid. Why? Because it is basic in nature. If you see this, Na, if this is dissolved in water, Na will form sodium hydroxide and this will form carbonic acid, and NaOH is a very strong base while carbonic acid is a weak acid. So the solution of this sodium bicarbonate will be basic in nature. That's why it is used as an antacid, as well as it is used in toothpaste. It is used for cleaning the ornaments that are made up of silver, and also at home for making your pakoras crispy, right? Baking soda is used for making baking powder also. Let's understand the difference in between the two. Baking soda produces carbon dioxide on heating, but it is not used for making cakes and pastry, because on heating, this baking soda produces sodium carbonate, carbon dioxide and water, and this sodium carbonate thus makes the taste bitter. So it is not preferred in cooking or making cakes and pastry. Now the baking powder. Baking powder is the mixture of baking soda and mild edible acid, and the acid that we take is tartaric acid. Now this baking powder is used for making cakes and pastry. Now the reaction that takes place, baking soda, when it reacts with tartaric acid, it forms carbon dioxide, water and sodium tartrate. If you don't remember the formula of tartaric acid, you can simply write hydrogen ions, because hydrogen ions, they come from the tartaric acid. Now when this baking powder is heated, the sodium carbonate, because when you heat this, the sodium carbonate will be formed, and this sodium carbonate is immediately neutralized by tartaric acid to form sodium tartrate, right? And the smell of this sodium tartrate is pleasant and the taste is also very good. So this makes the cake or any other food tasty. And of course, along with this, carbon dioxide is released. This makes the cakes and pastry fluffy and spongy. Now, another use of sodium bicarbonate is that it gives carbon dioxide on strong heating or when it is mixed with an acid. So, it is used as fire extinguisher. Now, washing soda. Washing soda, the chemical formula is Na2CO3.10H2O. Chemical name sodium carbonate decahydrate. It is prepared with the help of baking soda. Baking soda is prepared by ammonia, water, carbon dioxide, and sodium chloride. We get sodium bicarbonate, that is baking soda. Now, when baking soda is heated, we get Na2CO3, H2O, and carbon dioxide. And when sodium carbonate is made to react with water molecule, we get Na2CO3.10H2O, that is washing soda or sodium carbonate decahydrate. It is used in glass, soap, and paper industry. It is used in making detergent cakes and powder for domestic cleaning. It is also used for removing the permanent hardness of water. Water becomes hard if it has calcium ion and magnesium ions, and these ions are removed with the help of washing soda. It is used in the manufacture of borax, which is also used for cleaning purpose. Now next is plaster of Paris. The formula is CaSO4 dot half H2O. Chemical name is calcium sulfate hemihydrate. Hemi means half. It is prepared by gypsum. Gypsum is calcium sulfate dihydrate. When it is heated at a very high temperature, it forms plaster of Paris, and along with that water molecule is evolved. Now where it is used in hospitals by the doctors for setting the fractured bones in the right position to ensure correct healing. It is used for making toys and decorative materials. It is used for making surface smooth before painting. POP is done before painting. It is stored in waterproof container as it will solidify in the presence of water forming gypsum. So one has to be very careful in storing POP because if it is exposed into the atmosphere, it will absorb the moisture and it will solidify. So this table now here, the names of the salts written, the chemical name, the chemical formula, and the uses. So it's very important to know the common name of the salt, the chemical name of the salt, the chemical formula, and its uses.